Here's a video solution to a problem where you're asked to graph 2 to the negative x minus 4. And I'm sorry I had to extend the my grid here by hand a little bit, so I know it looks ugly at the bottom there, but we'll just work with it. So problems like this, like I said in a previous example video, start by graphing the parent function, which the parent function is always going to be, I'll write it again, a function of the form y equals b to the x, where the base is whatever base you're given. So in this case, we want to start by graphing y equals 2 to the x. Get that graph on your page first. That's the first order of business. Functions of the form b to the x always include the point 0, 1, 1, and then whatever the base is, so in this case 2, and a horizontal asymptote at y equals 0. So we can put those three key features on the page, and that'll help us get a decent sketch of the graph of 2 to the x. So it goes through the point 0, 1, 1, 2, and then I already drew that dotted horizontal asymptote at y equals 0. And I'll make this dotted just to make it clear. This is not my final graph, but here's the parent graph for this problem, 2 to the x. Now we have to think about what transformations need to occur to change that graph of 2 to the x into the graph of 2 to the negative x minus 4. So a couple of transformations need to occur. First, you've got this minus 4 outside of the exponential function. So this is a vertical shift down 4 units. Also, we've got that negative inside of the exponential function. So that's negative 1 times x. Since it's inside, that's a horizontal change. So this is going to reflect the graph horizontally, so across the y-axis. Reflect over the y-axis. Vertical shifts, like this down 4 shift, always go last, so we should reflect first, although these transformations are independent of each other, so it won't really matter. If you had, say, a vertical stretch by a factor of 2 and then also a vertical shift, then we would need to be careful about the order that we perform those transformations in. Okay, but so I'm going to apply those two transformations to these three key features that I used to graph 2 to the x, so the 2 points in the asymptote. And I'm going to start with the asymptote. So originally, we drew this horizontal asymptote at y equals 0 for the graph of 2 to the x. If we reflect that over the y-axis, that's not going to change this asymptote. It would look exactly the same when you reflect it, because it's already a mirror image across the y-axis. But shifting it down 4 would make a change in the graph. So you take this horizontal line here and pull the whole thing down 1, 2, 3, 4 spaces, or 4 units. And you end up, instead of at y equals 0, at y equals negative 4. So there's your new horizontal asymptote. Now we'd also move the 2 points. So take that point starting at 0, 1. Reflect it over the y-axis. Well, it's on the y-axis, so that's not going to go anywhere. And then from there, shift down 4 units. 1, 2, 3, 4. It'll land, 1, we came down 4 units, so it'll land at negative 3. Oops. So I'm going to plot a point right here. Okay. Sorry. Also, we have a point at 1, 2. Reflect that across the y-axis. That's going to flip to negative 1, 2 over here. And then from there, shift down 4 units. So if it's at 2, we go down 4. It's going to land at negative 2 right here. And I'm going to graph that new point right here at negative 1, negative 2. And then I'll draw the same shape of the curve going through those 2 points and then approaching the asymptote here. And so this graph in blue is our graph of y equals 2 to the negative x minus 4. Now I always like to go ahead and specify domain and range in these problems. Domain for all of these exponential functions that you guys see are going to be, domain is negative infinity to infinity. The range, we think lowest y to highest y. So the lowest y value in this graph, it gets very, very close to negative 4, but doesn't quite touch it. So we represent that in interval notation as a parentheses with -4. And then as far as highest y goes, this thing increases to infinity. There is no highest y value. So the range is -4 to infinity.